In this video, we're going to be going through how to show congruency in triangles. Now, congruency just means the same. So when we have two triangles that are exactly the same size and shape, we can call them congruent. Okay. Now, to be able to show that a pair of triangles are actually congruent, we need to use one of 4 tests. Okay, the first test is the side, side, side test. So this test means that all 3 pairs of matching sides are the same. Okay. So test number 2 is the side angle side test. And this one we have 2 pairs of matching sides that are equal, and the included angle is equal in both. So it's important that it's the included angle, and I'll show you what I mean by that in a minute. So the third test is the angle side test. So we need 2 matching angles are equal, and 1 matching side. Okay. And the fourth test is the right angle, hypotenuse, and side test. So we need a right angle in both triangles. We need the hypotenuse so the hypotenuse equal, and 1 other pair of sides have to be equal. Okay, so they're the 4 tests we're going to be using at this level. So if we look at this pair of triangles here, in this pair we're given this side here, okay, side AB has 2 dashes, and that's going to be this is equal to this side here, DE, because it also has these 2 dashes here. Okay, this side here, BC, is equal to this side here, EF, because they've both got 1 dash. Then we're given this little angle here, okay, and this angle here. And they've only got 1 line indicating the angle, so it's showing us that those 2 are equal. And the angle here is the included angle. Okay, it is included between our 2 sides. Okay, so we've got a side, an angle, then a side, an angle, then a side. So for this pair of triangles, we can use the side, angle, side test. This pair of triangles, we're not actually given any angles. Okay, so we don't know what the value of any of the angles are, or if any of them are equal to each other. But we are given this side here, DE, is equal to this side here, AB. This side here, FE or EF, is equal to this side here, BC. And this side here, DF, is equal to this side here, AC. So in this pair of triangles, we have 3 pairs of equal side length, so we can use the side test. This pair of triangles, we are given this angle here and this angle here is being equal to each other. This one here is called DFE here, and this one here, ACB, are equal. And this side length here, ED, and this side length here, AB, being equal to each other. So we've got 2 angles and 1 matching side, so we can use the angle side test. to show that these two are congruent. In this pair of triangles, we have a right angle in each. We have the hypotenuse, which is the side opposite the right angle. So this side here, DE, is the hypotenuse, as is AB here. It's opposite the right angle, so it's the hypotenuse. And they're equal to each other, indicated by the one dash on each line. We've got one other side here, AC on this triangle, and DF on this triangle, and it's showing us that they're also equal. So we've got a right angle, the hypotenuse, and one other side, so we can use the right angle, hypotenuse, side test. Okay. So let's have the test, how you can pick which test to use when you've got a pair of triangles. Okay, so we've got the right angle hypotenuse side test. We've got the angle side test because we've got two angles and one matching side in this pair of triangles. We can use the side test for this pair because we're given all three pairs of matching sides. And this one we've got the side angle side because we've got two pairs of matching sides in each triangle and the included angle. Okay, so it's important that it's the angle in between the two sides. Okay, so how do we use these tests? How do we show that our two triangles are congruent using the tests? So in that case, we've got this pair of triangles here. So when you're trying to work out which test is appropriate to show congruency in triangles, you just have to look at what information is given to you in the pair of triangles. So first things first, we just need to label our vertices. So we've got A, B, C for this one, D, E, F for this one. Okay, so for this pair of triangles here, our first pair, we've got two angles in each triangle that are equal and one other side. Okay, and our side is in the same, our known side length is on the same position in each triangle. Okay, it comes after or to the right of our 120-degree angle in both. So we can use the angle side test. Okay, so we've got two equal angles in the same position and one side length in the same spot on each triangle. So to write our proof, we have to show two angles and a side. So angle number one, and we denote angles using this symbol here. So the angle, this one here, we'll call BAC. Okay, so it's BAC is this angle here. And that's equal to this angle here, FED, or DEF. We'll keep it in alphabetical order. The angle DEF. Okay. This angle here, the 120 degrees, is called ABC. So that angle, ABC, is equal to this angle here, DFE. Okay. So we've got one angle, two angles, and now we need a side. So this side here is called BC, because we label sides by what vertices do they run between. Okay, so this one's BC, and that's equal to this side here, DF. Okay. So we've shown two angles and a side that is equal in this triangle, so therefore the triangle ABC is congruent to, and we use the equal sign with three lines, triangle DEF. So our second pair of triangles down the bottom here, we have a right angle, we have the hypotenuse on both, which is, remember, the side opposite the right angle, and we have one other matching side length. So we could use the right angle hypotenuse side test. So we're going to show that the right angle, the angle here, we need to again label our vertices. We call this one X, Y, and Z. This can be M, N, O. Okay. So we've got our angle here. This right angle is called X, Y, Z. And that's equal to, so to be Z, M, N, O. the angle MNO. So we've done the right angle. So now we need to label or show the hypotenuse is equal. So the hypotenuse on this first triangle here is called XZ, and that's equal to the hypotenuse on this triangle, MO. Okay, so MO is the hypotenuse on this triangle. So we've done the right angle, we've done the hypotenuse, now we need to do the side. So we've got this side here, XY, is equal to this side here, MN. Okay, so we've shown our right angle, we've shown our hypotenuse and our side. So therefore, the triangle XYZ is congruent to the triangle MNO. Okay, so we have another pair of triangles here. So this top pair, we've got the triangle ABC and this triangle here, DEF. So again, what information are we given that will allow us to choose a test for congruency? So we've got this side here, AB, then we have an angle 30, and then another side length here, 15. So we've got a side, angle, side in this triangle. This one we also have an angle 7 degrees, a side length of 7. We have an angle of 30, and then a side of 15. So here we've also got a side, angle, side. So for this pair of triangles, we can use our side, angle, side test. Okay. So the first thing we have to show is a pair of sides that are equal. So we'll say this side length here, AB, is equal to this side length here, EF. Need an angle, so we've got the angle BAC for this triangle is equal to this angle here, DEF. So the angle DEF. We need one more side, so we've got AC is equal to the length DE. So we've shown a side, an angle, and a side. So therefore, the triangle ABC is congruent to the triangle DEF. So for our last pair of triangles, this bottom pair here, we're not given any angles. So we can't use the side angle side test. We can't use the angle angle side test, and there's definitely no right angles, so we can't use the right angle hypotenuse test. So we have to use the side side test, which we have. We have 3 matching sides in each triangle. So this one we've got the side side test. So with this test we've got to show the 3 pairs of sides are equal. So the first side here we've got GH or HG. Try to go in alphabetical order. GH is equal to PR. Okay, so the next one, HJ, is equal to the side length PQ. And our last pair of matching sides, GJ, is equal to RQ. Okay, so GJ is here, RQ here. So we've got 3 pairs of matching side lengths, so therefore this triangle here, the triangle GHJ, is congruent to the triangle PQR. So that's how we show proof of congruency in triangles using 4 tests. The side test, the side angle side test, the right angle hypotenuse side test, and the angle side test.